Hello everybody, welcome back. Bio 142, Endocrine Lecture 3. We're going to talk about the thyroid and the parathyroid gland in this lecture. It's going to go along with Endocrine 3 notes, parathyroid, or thyroid and parathyroid for your PowerPoint. So speaking of PowerPoint, let's jump to that real quick. And all right, Endocrine 3, thyroid and parathyroid goes along with this lecture. All right. So anatomically, your thyroid gland, it's going to secrete thyroid hormone and also calcitonin, which we'll talk about toward the end. All right, it's in the anterior neck, superficial to the larynx. It's butterfly shaped. We're going to have right and left lobes. Let's get a picture here. Here we go. All right, so superficial to the, and also inferior here to the larynx. And it's butterfly shaped. We're going to have a right lobe and a left lobe, and those are connected by the isthmus. You'll want to know that for lab. Just posterior to the thyroid gland, you have the parathyroid glands, and 3 to 5 of them. And these have chief cells in them, which will make and secrete the parathyroid hormone, which we talked about in chapter 6. We'll talk about that at the end today. Alrighty, so your thyroid gland is going to make thyroid hormone. What exactly is thyroid hormone? It's actually 2 different hormones. So triiodothyronine, that's a long word, right? You do a triathlon, how many events are you in? 3, right? So 3, iodine, 3 iodines, and here they're calling it triiodothyroxine. And then T4 is just thyroxine, which you've probably heard of. So these are your thyroid hormone. So this is kind of interesting because T3 is more active than T4, but T4 lasts longer in the body. But many cells can convert T4 to T3. So T3 is more active, T4 lasts longer, cells can convert T4 to T3. And they can activate gene transcription. They also do, they increase metabolic rate by increasing both catabolic and anabolic reactions. So the net is about the same, but you're expending energy doing those reactions and creating body heat. Let's see if I can come over here. So you're creating body heat. These reactions give off energy, and you're creating body heat by doing them, increasing basal metabolic rate. Does that make sense? Here's your thyroid, right and left. So the right and left lobes connected by the isthmus. How about the histology of the thyroid gland? We're going to have, I'll show you on here, and then I'll show you a picture from the book. Now, the slides in lab look quite different sometimes than the book. Not all of them, but a few of them. So if you get to see any in lab, some of them may look a little bit different. But in general, the thyroid gland has bright pink colloid, what we call colloid. And this colloid is a protein-rich substance, and it's going to store 2 very important things. So you're going to store iodine in it, atoms, and you're going to store thyroid globulin. And you need both iodine and thyroid globulin to make thyroid hormone. All right, so what are these purple cells? These are follicle cells. All right, so the follicular cells, follicle cells. And then what are these other cells over here? Parafollicular. parafollicular, right? And they're going to have a different function that we'll talk about. Alrighty. Oh, and we sort of saw the picture here. So here are your follicle cells, and here's a colloid. Your parafollicular, they're not labeled in this diagram. Parafollicular. See how they're round? All right, so this is going to have iodine, and over here it just says precursor, but it's really thyroglobulin. It's going to be secreted into there. Alrighty. So what's it going to do? What is thyroid hormone going to do? We discussed this a bit. You're going to increase, I really like this, the sodium potassium pumps, right? We talked a lot about those. You're going to increase gluconeogenesis. Let's take that word apart. Glucose, new, genesis, making glucose from something new. So making it from skeletal muscle and from fats. And going to build proteins and fats. All right. So, and here it's talking about the energy getting released in body heat, which we talked about already. And how about, so promotion of growth and development and synergism. What does synergism mean? Acting together with the sympathetic nervous system. So it's going to increase or upregulate. Remember that term from video 1? Upregulate receptors for sympathetic neurotransmitters. What would that be? Like epinephrine, norepinephrine. So upregulate. You're going to make more receptors for the sympathetic neurotransmitters. And also it's going to affect blood pressure, heart rate. So higher thyroid hormone can increase heart rate and can actually be dangerous eventually. All right, so what is in that colloid? Remember, thyroid globulin is in there, and this is going to be that precursor. You're going to have iodine atoms. All right, so what's going to happen here is thyroid globulin abbreviate that way. It's going to be secreted into that colloid. Iodine atoms are going to get secreted in. Iodine ions, actually. They're going to be converted to iodine atoms. Thyroid globulin, hard to say, and iodine are going to combine. Now they can combine a couple different ways. You could have thyroid globulin with 1 iodine, or thyroid globulin with 2 iodines. So you can have T or T, let's with 2. But we actually have a term for this. For 1, if you, the term for 1 would be mono, so mono-iodothreonine, or di-iodothreonine. So mono, 1 iodine attached to it. Di-iodo would be 2 iodines attached to it. Now these two can combine, the mono and the di. So what do you get? If you have a 1 plus 2, you're going to have what we call T3, right? Or if you have 2 di-iodothreonines combined, you're going to have T4. Remember, we talked about those already. Does that make sense? How you get T3 and how you get T4? 1 plus 2, 2 plus 2. All right. So T4 lasts longer than T3, but T3 is more active. And here's a picture in the book, much better than mine, where thyroid globulin is made, secreted into the colloid, combines with the iodine, and is then combined, and you make T3 and T4. Pretty neat, isn't it? And can I just tell you, I used to work with thyroids when I was at NIH, and we had a special program for staining these because that colloid was so bright. It was truly about as bright as it is in my picture here, and in the pictures you see there. It's just not as bright as some of the lab slides, which perhaps is more pleasant to look at. But you could see a thyroid from across the room if it hadn't been stained on the special program that made it less bright. Thyroid was a lot of fun. All right, so how do we release thyroid? Well, we've already talked about that in the hypothalamus and the pituitary lecture, right? We have thyroid releasing hormone. Oh, you know what? Let me go back to the picture. We have thyroid releasing hormone from the hypothalamus, right? Thyroid stimulating hormone from the anterior pituitary. I was going to make you guess, sorry guys. And thyroid stimulating hormone stimulates the thyroid to produce thyroid hormone. So it makes more thyroglobulin. Now, let's say, what if we have the stimulator for our body saying, okay, make more thyroglobulin, but we don't have any iodine? Right. So if we need more thyroid hormone, but we don't have any iodine, what's going to happen? Well, our hypothalamus and our anterior pituitary, they're not going to know that we don't have enough iodine. So what they're going to do is say, make more thyroglobulin, make more thyroglobulin, make more thyroglobulin. And your follicular cells, your follicle cells are going to make more thyroglobulin, more and more and more. But are you going to get thyroid hormone? You're not, because you don't have the iodine you need. So what's going to happen? The colloid is going to enlarge and enlarge. You're going to get a larger and larger thyroid, and it's going to end up being a goiter. So why is this? Because normally, remember we talked a little bit about the feedback loop? So normally, you would get enough, if there was iodine, you would have thyroid hormone produced. And thyroid hormone would give negative feedback to both thyroid releasing hormone from the hypothalamus and thyroid stimulating hormone. It would provide a really, truly negative feedback there. So you wouldn't get thyroid hormone produced, and you wouldn't get thyroid stimulating hormone, or you wouldn't get thyroid releasing hormone, sorry, or thyroid stimulating hormone produced. So the stimulus to produce that thyroglobulin would not be there. But if you don't have iodine, you're not making thyroid hormone, and they're not getting that negative feedback because truly the hormone's not there, right? You need it and it's not there. So they're saying, hey, make this, but there's just not enough iodine. Does that make sense how a goiter is created? And you're making more and more thyroglobulin, so the sequence is working, except you just don't have that last iodine to make that, the MIT, the DIT, monoisothreonine, diisothreonine, to make triisothreonine and thyroxine. Does that make sense? That's something we'll talk about in lab too, but you really want to know that concept. I believe there's a question on the guided notes about it. And back when I used to have essays, I always put an essay on this question. Alrighty, let's go back to the PowerPoint. All right, so we talked about this. All right. So if T3 and T4 levels go down, thyroid releasing hormone and thyroid stimulating hormone levels increase. Right, here we have the tiers in the book. And I encourage you to watch this video at home. There's a video here on slide 16. All right, so different conditions: hyperthyroidism, hypothyroidism. You guys have probably heard of these. Hyperthyroidism, or one form is Graves' disease, where the immune system mimics TRH, TSH. So it's saying it's stimulating the thyroid. So what's going to happen here? you're going to get thyroid stimulation, not from the pituitary, but from the immune system. And you're going to make a lot more, not you, the person would make a lot more thyroid hormone. So what's going to happen? Thyroid hormone is getting made, and it's saying to TSH and thyroid releasing hormone, all right, turn off, nope, we don't need you, don't need you, don't need you. So thyroid hormone levels are going to be really high because the immune system is stimulating it. Thyroid releasing hormone levels and thyroid stimulating hormone levels are going to be really low because you have this artificially elevated thyroid hormone level. Does that make sense? So high thyroid hormone, low thyroid releasing hormone, and low thyroid stimulating hormone. All right, how about hypothyroidism? Or in a situation where someone has a goiter, well, first of all, you'll see that goiter. And second of all, are you going to have high thyroid hormone levels? No, you won't, right? But will you have high thyroid releasing and high thyroid stimulating hormones? Yes, you will. So it's the opposite of Graves' disease. You can also have congenital hypothyroidism, where an infant is born with low thyroid hormone levels, and that's actually very, very dangerous for them. Can have long-term effects. So babies get tested for it when they're born. All right, here's a picture of someone with a goiter here, and simply caused by low iodine in the diet. Sometimes you see it more in landlocked countries where iodine isn't added to the salt. Alrighty. So we talked about the negative feedback loops. And hypo, so if you're unable to produce T3 and T4, you're going to have high TRH, TSH. All right. If the thyroid's artificially stimulated by the immune system, you're going to have high thyroid levels, but low thyroid stimulating, low thyroid releasing hormone. Does that make sense? All right, let's move on to calcium ion homeostasis. All right, so we've talked about this in chapter 6 for 141, in the bones chapter. So what hormones did we discuss? Parathyroid hormone. Oh, we're going to talk about the parathyroid today. And calcitonin. So what did these do? Parathyroid hormone raised blood calcium levels. Calcitonin lowered blood calcium levels. All right, so where are they made? Chief cells in the parathyroid hormone, parathyroid, secrete parathyroid hormone, chief cells. I think of calcium, and well, it doesn't sound like chief, but they all start with C, so that kind of helps. Thyroid hormone, or the thyroid gland secretes calcitonin. And these are they synergists or antagonists? They're antagonists, right? One raises blood calcium levels, one lowers blood calcium levels. Keep us in homeostatic range. All right, parathyroid, when the blood calcium decreases, parathyroid is stimulated, the chief cells, and what are they doing? They're monitoring the blood itself. So is this hormonal regulation or neural or humoral? It's humoral because they're monitoring the blood levels directly. Alrighty. So what is it going to do? How's it going to do this? So chief cells are going to secrete, you know what, let me go to the board here. Chief cells are going to secrete parathyroid hormone right here. And what is it going to do? Let me get a little closer. So parathyroid hormone is going to increase bone resorption from osteoclasts. Remember in chapter 6 we talked about those osteoclasts, how they resorb bone? And also we're going to activate vitamin D, which is going to increase absorption of calcium by the small intestine. You also can increase the reabsorption in the kidney tubules. So the kidney is going to excrete calcium but we don't want to, right? We need to hang on to that so we can reabsorb it from the kidney tubule. You know, I think of this a little bit as if you need some cash, what can you do to get it? Well, we can go to the bank and pull some out. So the bones are kind of like the bank, the calcium bank. I could do something to get more money, like get a second job. And that'd be a little bit like increasing absorption in the kidney, in the small intestine, sorry. And I could just spend less. That would be like increasing reabsorption in the kidney. So you have resorption, absorption, and reabsorption in this case. And that is what parathyroid hormone is doing. Does that make sense? I'm pulling from the bank, getting a second job, increasing my absorption in the small intestine, and spending less. I'm getting rid of less in the kidney. Resorption, absorption, and reabsorption. A little tricky because of the words, but does the concept make sense? So I do those things. Calcium, blood levels in the calcium increase, and I go back to homeostatic range. That makes sense. I'm hoping it does. I wrote it out here, even though it's in the PowerPoint, because in the past I've always put an essay question on this, both here and in Chapter 6 and 141. All righty. And here's exactly what I was talking about just now. Stimulus, low blood calcium. Receptor cells are those chief cells in the parathyroid. Control center, also chief cells, but here they're secreting the parathyroid. Oh, but remember with the receptors, that's hormonal. Or not hormonal, sorry, humoral, not hormonal. Humoral because it's sampling the blood, testing and monitoring the blood levels itself. All right, effector and response would be those three things, the resorption, absorption, and reabsorption. Here's a picture. I love this picture because you could see the bone, you could see the kidneys, you can see the small intestine. If I were a student going to take a test, I'd really want to know this. All right, how about calcitonin? What does it do? Calcitonin is going to be released when the blood levels are high. Too much calcium in the blood, out of homeostatic range. So what's it going to do? It's really going to go after those osteoclasts and inhibit them. That allows the osteoblasts to build up the bone. That's going to decrease the blood calcium levels. It's also going, I guess it doesn't talk about it here, but it'll act in the kidneys as well. All right. So one thing I want to point out, do you remember back in Chapter 6 we talked about estrogen and how it sort of inhibits those osteoclasts? So here's one of those hormone interactions. Are they synergists or are they antagonists here? Here, they're synergists, estrogen and calcitonin. Kind of fun. All right, so here's a chart. I love these charts. It just takes all the paragraphs before them and organizes it nice and simple. If you're a chart person, I'm sure you'd love these as well. And osteoporosis, right? Bone density. So what does that have to do with this? Well, if we have low bone density, we can risk fractures. And estrogen, how's that going to play a role in this? If you have higher estrogen, you're going to have more the osteoblasts are going to be more dominant over the osteoclasts. But what about when estrogen levels fall? Or if parathyroid levels are very high, or calcitonin levels are too low? Then you can have more resorption of the bone than bone deposition by the osteoblasts, and that can cause problems. All right, well, thanks guys for listening to video 3. I'll work on getting video 4 up for you guys, and give me feedback if it's not working for you. Also, Dr. Rogers' videos are up, so it should have similar information. All right, take care everyone. See you tomorrow, 5:15. See you on Zoom, I should say. All right.